All right, let's try this one more time. Let's see if it works now. Yes. Okay, here we go. So these are called properties of exponents. So we're going to talk about exponents, at least in the first part. We'll probably be doing a whole lot more with exponents. This is just real basic stuff just to kind of get you warmed up. Eventually you'll do that a lot. So let's do multiplication. So multiplication with exponents. So we'll start off we'll just do variables right now. So x to the a times x to the b. The bottom number, what do we give it a special name? What is that bottom number, that x, called in math? It's the base. Very good. Okay, and what's the a and the b? Exponents. Okay, pretty easy. So you got bases and exponents. So this rule works only when the bases are the same, all right? Because you really can't multiply them together unless the bases are the same, okay, at least using this rule, all right? So what we do is we keep the base the same, and even though this is a multiplication problem, what do we do to the exponents? We add the exponents, all right? Again, that's a very basic Algebra 1 topic, but we're just hitting it again so that we are on the same page. What about division? So let's go x to the a over x to the b. And we'll do some examples here in a minute. I'm just going to give it to you like this at first. So they got the same base and you're dividing. So you keep the base the same, and what do you do with the exponents this time? You subtract. So I'm going to put a minus b. All right. Now we have a thing called the power rule. This is when you have an exponent to another exponent. So if I have x to the a, we're going to take that to another exponent. Let's take it to the b power, right? Can you what? Nurse. You weren't sick when I was telling all my stories. Why are you sick now? What's she going to do? Just stretch it out. Yeah, you can. Stand up, put your toe down like this, right? Put some pressure. Is it your calf? Yeah. All right, just stretch it out. What's she going to do for you? She going to kiss it and make it better? You're all right. All right, let's do this. So if it's x to the a to the b, what do we do with the exponents here? That's it. We multiply them together, so we can just put them together. So if this is a 3 and a 2, then it would be x to the what? 6. Everybody good? Yeah. This is stuff that you already know. Here's another rule. What if you had something like this? They call this the power of a product. At least this book does. I don't think I've heard anybody else call it this, but we'll call it since the book does. Power of a product. What in the world does that mean? Well, you'll see. It does make sense when you see this. So what is the power of a product? It's when you have like x times y to the a power. You could almost do this in your sleep, but we're going to do it anyway. It's a rule. So what does this mean? X, y, see there's your product, right? Two things that are being multiplied together, and there's your power. That's why they call it the power of a product. What do you do here? How can you extend that out a little bit? What would it be? X to the what? X to the a times what? Y to the a, all right? You kind of already know that. Some people might look at it and say you distribute the a, distributive property, but nah, not really. It's not really distributive property, okay? It's this. It's the power of a product, all right? Same thing, power of, I'll just write this down. I won't look power of every single time. Power of a quotient. What's a quotient? Product means you multiply. What's quotient? You divide. So what do you think that's going to be? If I have x over y to the what? A, we'll call it. So how can you extend that? How can you rewrite this? X to the a over y to the a. Very good. Okay, so basically you're just taking everything in that parentheses and taking it to the a power. Same thing with this. You take everything in the parentheses and you just take it to the a power. Everybody good with that? All right, good. Let's talk about, let's come up here. Use this space. I said we were going to do examples at the end. I actually did put examples for each one of these, but I don't think you need examples for this. I think you know this already. So let's do a zero exponent. Zero exponent. So if I have something to the 0 power, anything, it doesn't matter, any real number, to the 0 power is what? Is it? 0. It's not 0. It's 1. okay? Let me show you why. A lot of teachers don't show you why. I like to show you why. Well, this is like a simplified version of it. But what if you had like x to the 5th over x to the 5th? Now, you could look at it two ways. You could say, oh, anything over itself is equal to what? Equal to 1, okay? Or let's use that division rule right here. What does the division rule say? We keep the base the same, and what do we do with the exponents? We subtract. So it's what? 5 minus 5, which is what? X to the 0. And what do we say anything over itself was equal to? 1. So what's x to the 0 equal to? It's 1. So that's why that's true. A lot of times teachers don't show you that, but I think it's good to see that. That's why that anything to the 0 is 1. You can put it in the calculator, and you can see that that's true. All right, what else we got? Oh, negative exponents. Now we're starting to get somewhere. Negative exponents. I'm not going to write that down, but I will do this. What does that mean? That's an n. It's a lowercase n. X to the negative n power.
1 over x to the n.
Very good. It's 1 over x to the n. What this means is this. Like, you could put anything over 1, can't you? If you have a negative exponent, what it basically means is to take that whole thing, all right, take that whole thing, flip it, and once you flip it, you got to change one thing. What do you change? The sign of the exponent, all right? Wouldn't that be the same thing? Well, if I flip this, there's nothing else left on top, right? Well, now there is, because it's always 1 times something. Yeah? So we take this, flip it to the bottom, change the sign of the exponent. All right, so 1 times x to the n is x to the n. What's left on top after I take this and flip it to the bottom? That 1's still up there, isn't it? All right, so we write it 1 over x to the n. So for instance, if you had 3 to the negative 2nd, what is that? It's 1 over 3 to the positive 2nd, which is 1 over 9. Or you could have this. You could have 1 over, well, you still use that same one. What if you had this? Well, you don't want the negative exponent. You never want a negative exponent. So you flip it where? To the top. That's right. So if it's already in the bottom with a negative exponent, flip it to the top and change it to what? 3 to the positive 2nd. That's 9. We good with that? Again, we're going to be doing a lot more with that. We're going to have things where you got like x cubed, y to the negative 8th, z to the 4th, over, blah, blah, blah. And you got to simplify it. You're going to have to move things top and bottom all the time, okay? So you're going to have ones that are a lot more involved, but the rule is the same. So we got to learn the rule first, and then we'll do a whole bunch of stuff with it, all right? And here's one of those examples. This is exactly this example that I was thinking of. I didn't think they would get to it right away, but they do. So here's example 1. It's in the book, and we got several parts. Part A, B, C, and D. So I probably will not do all of them just for the sake of time, but we'll do a couple of them. Let's do the first one they give you. So it's parentheses, and it's 4, I think that's a squared, 4x squared y, and that's negative 3. So we're going to apply the rules that we've been learning with this example, y to the negative 4th. All right, in case you can't read my writing, it's 4x squared y times negative 3, x to the negative 2nd, y to the negative 4th, okay? So the first thing we do, we're going to multiply. We're just going to multiply the stuff. Like if it's just a regular number, we're just going to multiply those numbers together. If you have the same base, that's the only way that you can multiply them together if they have the same base and they got exponents. So let's do the regular numbers first. So what do I got? I got a 4, and what else? A negative 3. So multiply those, negative 12. Easy. Let's do the x's. All right? So just the ones with the same base. So I got an x squared and an x to the negative 2nd. So what's the rule when I'm multiplying? What do I do with the bases when I multiply with exponents? I add the bases together. So this is going to be x to the, what is it? 2 plus negative 2. 0. So what's that eventually going to go to? It's going to go to 1. We'll do that in the next step, okay? What about the y's? This is y to the what? To the first, okay? And what do? We add them up. It's 1 plus negative 4. What's 1 plus negative 4 or 1 minus 4? It's negative 3. Here's another thing. They rarely ever want you to keep your exponent as a negative. Okay, even if they don't tell you to change it, you should change it. So we don't want to keep our negative or our exponents as negative. So we're definitely going to have to do something with that, and we're going to definitely do something with that. Everybody with me? So equals negative 12. Well, this one right here is easy. What is it? It's just a 1, and 1 times negative 12 is just negative 12, so simple. What do I do with this one? Right now, it's in the numerator, isn't it? So what am I going to do to it? Flip it and change it to y to the positive third. So once I flip it, I got to change the sign of it. All right, so if it's on the top and it's negative, the exponent's negative, I flip it to the bottom and I change the sign of the exponent. And that's it. That's how you want to write that answer. That's the simplified version of this. By the way, I didn't tell you that. They tell you to simplify this stuff right here. All right, and that is the simplified answer. You see how I showed my work? Make sure you do that, okay? Show your work, circle your answer, and you're good to go. Let's do one more. Let's do C. And you can always look at B and D on your own. But I need to get a little further today. So let's go negative 2, A, C to the 4th over 5b cubed. 5b cubed. Oops, that's a weird looking 3. There we go. And all that is squared. Okay? I forgot already what time you get out of here. 2:05. Okay, so I got 15 minutes. So what do we do? Remember that rule, what do we call it? The power of product or power of quotient or something like that? Okay, we're going to basically do that. So everything in here is being taken to the second power. So we have to take the negative and the 2. So this is not going to be negative 4. What's it going to be? This thing to the second power, which is it positive or negative? Why is it negative? It's positive 4. It's positive 4 because we're squaring the negative. If you square a negative, it's what? It's positive, right? So this is going to be what? 4. Okay? What about the A? A to the second. What about the C? Yeah, is it 6 or 8? I heard both. Why? Because it's that power rule. Remember, when you take an exponent to another power, that's when you multiply them together. All right? So that's going to be C to the 8th. All right? Bottom, 5 squared. Again, we square everything, even the bottom stuff. Okay? So 5 squared is 25. And then B cubed squared. That's B to the 6th. Is there anything we can do? Can we flip anything? Can we multiply anything else together? Can we simplify that 4 over 25? Nope, there's nothing else we can do. So we circle it, and that's our answer. Okay? All right, we're moving right along. We might be able to actually finish this. Let's talk about some definitions. First of all, let's talk about a polynomial. Oh, we already did that? We did monomial, binomial, and all that? Fantastic. Did we do the degree? We didn't talk about the degree of a polynomial. Okay, so the degree of a polynomial. All right, because you're going to have some questions today. What is the degree of the polynomial? So I'll just read the definition. I won't write it down. It says the degree of a polynomial is the highest degree term in that polynomial, right? And we usually write it in descending order. What does that mean? Descending. Go from the highest exponent all the way down to the lowest exponent. I'll show you what I'm talking about. So what if I had 2xy? So in order to find the degree of the polynomial, what I do is I find what my exponent is. Like, how much do all my exponents add up to be? All right? So what's my exponent for the, and these are only for the variables, not for the actual numbers in front. So the x and the y. What's the exponent for that variable right now? It's 1. What's the exponent for that y? It's 1. So what is the degree of this term right here? It's the number of exponents. If you add up all the exponents, what do you get? You get 2, right? So we call this a second degree, or we just say the degree is 2, all right? But a lot of times if they're smaller numbers, we call that a second degree, and it would be a monomial because it's just a one-term thing, all right? So let's do a couple more. What if I had 5x squared y? What's the degree of this polynomial? Or it's not really a polynomial, it's a monomial. It's 3, right? Because the x has 2 for an exponent, the y has 1. How many exponents altogether? 3. So this is a what? Third degree. Okay? Everybody with me on that? All right, let's do an example. So you get the idea for that. Let's do example 3. We'll do it right here. So I'm going to give you an actual polynomial with more than just one term. I mean, this technically is a polynomial, but it just has one term. Let's do one with more than one term. So I got 4x cubed y plus 7x squared y cubed minus 15 y to the 4th. And I want to find the degree of the whole entire polynomial, not just individually, but the whole one. What is the degree of the whole polynomial? It's whatever term has the highest degree, all right? So I find the degree of each of the terms, just like I did here. What's the degree of this polynomial? That's a 4th degree. What's the degree of this? That's 5th. And what's this? It's 4th. So what's the degree of that whole entire polynomial? It's the higher one, right? So what is the degree of that polynomial? It's a 5th degree polynomial. We good? All right, enough of that. Let's do another thing. Combining like terms. Again, a very basic Algebra 1 topic, but Algebra 2 is basically taking the stuff that you learned in Algebra 1 and just like taking it a whole big step further than what you did in Algebra 1. And that's kind of like this. All right, I mean, the first example is not really going to be like that. So we know what terms are, so let me just give you a quick example. I'll just do 2 of them. I got 2 of them written down. Tell you what, I'm only going to do 1 of them. I think that's good enough. I'm going to do example 4b, because that's definitely the longest one. So here we go. So it's 2a times 2a squared b plus ab minus 4b cubed. We're only halfway done. Minus, this is 5a cubed b plus 3ab squared minus 4, we're almost done, we're almost done writing down the problem. There we go. All right. So some books might say simplify, some may say add or combine like terms or something like that. So that's basically what we're doing. Okay, we're combining like terms. We're just simplifying it. So most books probably would say to simplify. All right. So where in the world do we start? The 2a. What are we going to do with that 2a? Yeah, give me a good math word that fits here. What is it? Distribute. Very good. We're going to distribute. So we're going to take that 2a and we're going to distribute it through everything there, okay? So I'm going to multiply everything by 2a in that first parentheses. Everybody got that? So let's do that real quick. So 2a times 2a squared b. So 2 times 2 is 4a what? Cubed b plus 2a times ab. 2a what? A second, or a squared, we'll say. B minus, right here. 2 times 4, 8. There's no a here, so I just write what? A b cubed. Okay? That wasn't hard, right? A little distributive property. Minus. So what does that mean? What are we distributing here? We're just changing all our signs, aren't we? So instead of positive 5a cubed b, what's it going to be? Right, minus 5a cubed b. What's this going to be? Minus again, right? 3ab squared. What's this going to be? It's minus a minus, right? That's going to be plus. And we just write 4ab cubed. Are we done? Not really. We only got to the point where they really want you, what they want you to do. You want to combine like terms. So remember, you can only add like terms. You can't add an x plus a y, all right, if you don't know what x and y is. So they got to be the same exact term. So let's take the first look at the first one. Now, the numbers out in front, by the way, do you know what the name of that number out in front is? Starts with a C? Nope. Constant is just a number sitting there by itself. Starts with a C, though. C-O. Nobody? E. Coefficient. There you go. I knew you'd know that word. You've heard that before. So the number out front is called the coefficient. So I'll refer to it as that. All right. So don't worry about the coefficients in order to find the same terms. Okay. Combine like terms. Just look at the variables and the exponents, and they can even be in different order. All right. But they got to be exactly the same. So this is a cubed b. Are there any other terms in here that have a cubed and b together? Yeah, right there. All right, so this one does, and this one does. Any other? A cubed b? No, that's an ab cubed. Is that the same thing? No. So I'm going to add those two together. So that's what we mean by combining like terms. We just add the things that are the same together. So here's where the coefficient comes in play. So how many a cubed b's do I have right here? 4 of them. How many do I have here? -5 of them. So 4 minus 5. What's 4 minus 5? -1. Do you really need the 1? Don't really need it. But what's our term? A cubed b. Now, when you have a big, long stretch of these things, I don't know about you, I like to mark them out so I know I'm done with it. Okay? Let's do the next one. This is 2a cubed b. So squared. A squared b. Is that a squared b? Nope. A squared b? Nope. A squared b? Nope. There's no like terms. So what can we do? Just add it or just put it next to it, okay? There's no other a squared b's, so that's the only thing we can do. I'm going to mark it off. What's this one? ab cubed. Any other ab cubes? Yep, this one right here. -8 plus 4, -4 what? ab cubed. Done with that one. What do I have left? Just this. There's nothing else to add it to, so I just write -3ab squared. And that's it. That's how you do it. It's pretty simple, isn't it? Yeah. I think that's good. Pretty good timing, huh? Even with all the storytelling we did earlier. Still finished it. All right, here's your homework. Section 1.3. There's no A or B on this one. It's page 14. And you probably have it on the lesson plan I gave you yesterday, right? Double check to make sure it's the same one. I'll tell you what, I'll take it easy on you. I did say all, okay? I don't know if I'm making it too easy or not, but I'm in a good mood. So I'll just give you the odds, okay? So if you look in the if you look on that lesson plan, I just think it says 1 to 31, right? But I'll just give you the odds, all right? So just do the odds. Everybody good? All right. One of these days, well, I was doing one of the lessons, a couple lessons from now. I'm like, I think we're finally starting to get into a little bit of Algebra 2. So we'll eventually kind of get out of the Algebra 1 mode. But they do that with every book. You know, they start off with a little review thing just to get the summer out of your head. And that's what they're doing here. All right.